All right. So the first thing that I want to do is make sure that your calculator's window settings are set up right. Okay, so I'm going to call this step 0. Since we're going to be using the graphing utility on this, I want to make sure your window settings are set accurately. And so the way to access your window settings is green diamond F2. Okay, so if you hit this window button, oops, green diamond F2, your default settings should look like this. The minimum should be -10, the maximum's +10, and the scale, SCL, should be 1. And so it should go X minimum -10, X maximum +10, the X scale of 1, and then same for the Y's. Y minimum -10, Y maximum 10, the Y scale 1. If you have a command at the very bottom, you can leave that. You don't need to change anything at the bottom as well. Okay, the scaling just means that every hash mark that you see on the, or tick mark you see on the graph represents 1 unit. And then for the most part, the graphs that we're going to be looking at will fall within this viewing window. Okay, if it turns out that they don't fall within this window, I'll show you later how to adjust the settings, but this is where you should start at the beginning of any of them. Okay? So that means your first step then, after making sure your window settings, Eric.
How do you change it to the X?
You don't need to change that at all. All right, so once you get your window settings accurate, what you need to do is you need to enter the function into your Y editor. All right, if you recall, the Y editor is located at the green diamond F1. So if you hit the green diamond button and then F1, you'll access the Y editor. And we're just going to type in the equation, this whole function in there. Now notice, you don't need to type in the Y equals. Remember, our Y, this is really going to be Y1 equals. So we just need to type the expression of this. So -3x squared plus 12x minus 6. And once you enter that into your Y editor, okay, that's pretty much the only work that you have to do. The rest is just kind of viewing and going into the viewing window of the graph. Okay, once you hit enter, you're now going to view the graph of this. And the way that you view your graph is green diamond F3. Okay, so now we have that selected. We go into our graph and it should show you the parabola, show you the graph of this function. Okay, once you see this graph,
I'm clicking the same thing. I got it open.
check, you probably didn't have a -3x. All right, is everybody at this point? Were you able to get it?
Yeah.
All right. So once you get to this step, you can now take a look at you can answer the questions based on the graph tendencies. Okay, so looking at this graph, can you tell whether this opens up or down? Here it opens down, right? The parabola is a U shape upside down, so it's opening down. Can you tell here whether this vertex is a maximum point or a minimum point? Is it the highest possible point or the lowest possible point of the graph? It's the highest possible point, right? So it's a maximum. Okay, and then as far as this telling whether the graph is more narrow or wider than the parent function, that all has to do with the leading coefficient. And so if you look at the leading coefficient A, and the absolute value of A is greater than 1, okay, it's going to be narrower. It's a vertical stretch. Because we've used the term stretch already. Okay, and So in this case, the value, absolute value of -3 is greater than 1, so this graph is going to be more narrow than the parent function. Okay, had it been absolute value that is less than 1, then it would have been a wider graph, meaning that it would have been vertical shrink. Okay. All right, so you can identify and answer the questions based on the tendencies of the graph. Okay, there's a few other things that you can do on this, but let's kind of just go down this list here. Okay, let's now find the vertex. All right, in order to find the vertex, we're going to go into this Math tab, F5. And we're going to choose whichever one we selected here. If the vertex is a minimum or a maximum, you're going to choose either 3 or 4, based on whether you're looking for a minimum value or a maximum value. So here we determined that our vertex is a maximum, so we're going to choose number 4 for this. Okay, once you get to this step, it's going to ask you two things. It's going to ask you to find a lower bound and an upper bound. Okay, what this is asking you to do is it's basically asking you to find a value of x that falls to the left or to the right of the point that you're looking to locate. Okay, so the lower bound means an x value to the left of the designated point. So we can see where our vertex is going to be, right? Our vertex is somewhere around 2. Okay, there's no guarantee that it's exactly 2, but we see it's somewhere around there for our x-coordinate. So as long as we pick a value of x that's to the left of that, so any number less than 2 will work. So if you look at where my crosshair is right here at 0.12658, is that less than 2? Yeah, it's to the left of our vertex. So I could just hit enter right here. Now, if you want consistency and you want to always enter a value, what I would suggest is just pick the value on the furthest end of the viewing window. So would -9, so located right here, would that be to the left of this vertex? Yeah. So if you want, you could just type in a -9. Now, like I said, you can leave it as the crosshair if you want, or you can select a number. So I'm going to choose -9 here. And then it's going to ask me for the upper bound. The upper bound is going to be an x value to the right of my designated value. So I need to pick an x value that falls to the right of my vertex. So if I picked 0, would 0 fall to the right of this number or this vertex? No. But what if I picked a number like 3 or 4 or 5 or 6? Yeah, so anything over here to the right of this. And again, just to be consistent, I'm going to pick the furthest I can, which is 9, and still be a single digit, so it's efficient to type in. Okay, so this number 9 is guaranteed to be to the right of my vertex, so I can hit enter. And now it's going to give me the highest point of my graph between -9 and +9, which is the vertex, and it labels it right here, and you see the point is 2, 6. And so you're able to identify your vertex. And now remember, we talked about a vertex in the last class. We could find this by looking at our A value, our B value, and our C value, right? And we could say that the vertex has an x-coordinate at -b over 2a. So we could confirm that too, right? We could have done that by hand, but if we can identify everything just by looking at using our calculator, it's very efficient that way. Okay, once we find our vertex, the axis of symmetry is very easy. Okay, so that would be the next step. Oops. The axis of symmetry is just going to be the vertical line, x equals whatever your x-coordinate of the vertex is. So in this case, x equals 2. So once again, we would take this. This would simply be the equation x equals -b over 2a. But it's just whatever the x-coordinate of your vertex is. All right, next, identify your y-intercept is very easy. Because when you look at your graph, if the graph is, or the function is given in standard form, the y-intercept is simply going to be your c value. And the y-intercept is just our constant. Remember, it's an ordered pair where x is 0. So when x is 0, these terms disappear, you're left with just -6. So once again, your y-intercept is just going to be the point 0, c, whatever your c value is in standard form. So remember, your standard form is y equals ax squared plus bx plus c. So whatever your c value, your constant, is going to be your y-intercept. Okay, probably the hardest thing to do is going to be to find the x-intercepts. Okay, there's two ways that you can find this. Okay, you can find it on staying in the graph form, or you can go to the home screen, just the main calculator part, and you can find it there. Okay, I'm going to show you the main calculator part first because I think that's the easier way to do it. Okay, so there's two ways to find the x-intercepts. The first way is to go to the home screen. So if you hit home, go back to your calculator. And what you can do is you can use the solve feature, and you can solve for the equation of your y function. So y1 of x using function notation. We can pull that function into our calculator by using y1 of x. And we can find what values of x is going to make that equal to 0. And so we can use this entry on our calculator. So F2, the algebra tab, choose solve. Access our y1 function, so y1 of x. We want to find where is that equal to 0. So where are the y values equal to 0 for this function? And we want to find what values of x will give us a y value of 0. Okay, and so when I enter that, I'm going to get my two solutions. So if I don't hit the green diamond button, it'll give me the exact answer in terms of radicals. In this one, I'm going to use the decimal form, so I could have used the green diamond button. And I get my decimal values, 3.41, and if I look to the right, 0.59. So if I put 0.590, that's one x-intercept. And then my other one, the one that's further to the right on a number line, is 3.410. Okay, so those are going to be my x-intercepts. Okay, so in my opinion, this is the easiest way to find it. And now, if you wanted to stay in your graphing window, you can also use commands there to find these, but it's a little more tricky and it involves the upper and lower bounds. And so let me talk about how to do it on the graphing window. So if I go back to my graph, green diamond F3, okay, I can see where my intercepts are, right? I can see that 1 is just a little bit less than 1, and 1 is just a little bit more than 3. So these values are consistent with what I see on my graph. But if I want to find what those x-intercepts are located here, I'm going to use my F5 math tab. But now it's going to be called zeros. So these are the x-intercepts are also called zeros. Okay, so we could have used this math tab and selected zeros, which is number 2. And once again, it tells you lower and upper bound. Right? You have to do. Okay, so don't use value. Use the 0, number 2. Okay, I'll have to take a look and see why that is. All right, so when you set up to find the zeros, it's going to ask you for a lower and upper bound. Notice how many zeros do we have in this function? We have one here and one here. We have two different ones, right? So you have to use the lower and upper bound to distinguish which one you're talking about. So if we look at this point right here, we need to pick some value that's to the left of this point. So we could use any negative number. Could we use 0? Yeah, could we use -9? Yeah, so I'm just going to use -9 again. And then choose my upper bound. Now notice, with my upper bound, I need to pick some value to the right of this point, but it can't be to the right of this second intercept. So I have to pick a value in here somewhere. So again, you could either scroll along your graph. And so if I'm scrolling my crosshair, as my crosshair shows up, as long as I go to the right of this intersection, which it's now to the right of it, I can continue to go if I want to, but I could stop anywhere to the right of this. That's my upper bound, and it'll pick the 0 that falls between those two, the lower bound and the upper bound. So if I stop right here, hit enter, it's going to give me this solution point. And so as it calculates it, you see that it's 0.59. And then I can find my other 0 doing the same thing. F5, choose 0, number 2. My lower bound has to be to the left of this point, but it can't be to the left of my other 0. So where my crosshair is right now is fine. I can still choose anywhere along here. Once I get to this point, it's a little more risky to push it, so make sure it's exaggeratedly to the left. So here my crosshair is to the left of this intersection. There's my lower bound. Choose my upper bound, anything to the right of that. So as long as I scroll along my graph, once I get past that 0 or that intersection, I can now hit enter, and so my second 0 will be at 3.41, which again I already found. Okay. Can you guys see how the solve feature is easier if you understand how it's used? And it's probably a simpler approach. Right, the last thing that this asks you to do is evaluate. Oops. So step 8 is going to be to evaluate. Once again, there are 2 different ways to do it. You can go to the home screen, or you can stay in the graph screen. Staying in the graph screen is still pretty easy. If you hit the F5 Math tab once again, and you just pick value, you can type in the value you want to evaluate for. So just type in a -2, and when you hit enter, you get your solution. In this case, a -42. Okay, so that makes it really easy to evaluate the number there. And now the alternative for this would be to use the home screen. And if you wanted to evaluate in the home screen, you are going to use function notation, so y1 of, and you just plug in the number that you want to evaluate for. So y1 of -2, if we go to the home screen, we can type in y1 parentheses -2, use the function notation representation to evaluate, hit enter, and it confirms -42 also.